Welcome back. This is part 4 of the prerequisites chapter, section 1, and here we'll be talking about ordering real numbers and absolute value. So we can draw a number line. This is probably something you're familiar with. We can draw a line and we can pick a point on that line and we'll call it 0, and then we'll evenly space the numbers to either side, and we can represent these numbers being ordered in some way. So note that I haven't written down all of the real numbers. There are infinitely many, and also there are a lot of numbers in between here. So for instance, in here somewhere it would be the number 1/2, and then maybe out here will be the number -pi. So there's lots of numbers, not only the ones that I've marked, but also lots in between. And we can say that a number is less than another number. So A is less than B. We use this notation for that. And this means that A is to the left of B. So for instance, 1 is certainly less than 4 as an example. But we can also say A is greater than B. So again, I could just switch this around. I could say 4 is greater than 1. But also 4 is greater than, say, -2. And when we look at this number line, numbers that are less than, so numbers that are smaller will be to the left, numbers that are bigger will be to the right. But we can also write less than or equal to and greater than or equal to. And this can be either or. So for instance, 1 is certainly less than or equal to 4. But you know what? 1 is less than or equal to 1. It's equal to it, so the or equals part is quite important. Likewise, I can say that 4 is certainly greater than or equal to -2, but at the same time 4 is greater than or equal to 4. So when we look at a number line, we can also talk about the distance between numbers, not just whether or not they're to the left or to the right, and this is going to be the absolute value. Traditionally, we think of the absolute value of a number just making that number positive. So if x is positive already, the absolute value of x is just going to be x. If x. And what do I mean by positive? I mean that it's going to be greater than 0, but we also say that it's going to be equal to x if it's greater than or equal to 0. So note, the absolute value of x is equal to the absolute value of 0 is equal to x. Likewise, if x is negative and I want to make it positive, I'm going to add a negative sign. The negative signs will cancel out and make this a positive number. So x, if x starts out being negative, the absolute value of x is just going to be -x. And one way to describe this is the absolute value of x is the distance from x to 0 on the number line. So for instance, the absolute value of 2, well, 2 is already positive, so the absolute value will just be 2. But the absolute value of -3, if we follow our formula, -3 is certainly less than 0, so I add a negative sign. So this is going to be -3, and -3, the negative signs will cancel out, and we just get 3. Very quickly, if we come back up to our number line, and we look at the distance from -3 to 0, we'll see that we have to go 1, 2, 3 over. So the distance from -3 to 0 is in fact 3, which makes sense. The absolute value has some nice properties, and these are important to keep in the back of your mind because they'll make simplification a lot easier later on. So the first property is that when you take the absolute value of a number, it's always going to be greater than or equal to 0. When you take the absolute value of a number, it'll either be positive and greater than 0, or you happen to start with 0 and the absolute value of 0 is just equal to 0. The second one is that when you take the absolute value of a number, and you take the absolute value of negative of that number, you get the same. So when we think about on a real line, 2 is the same distance from 0 as negative 2 is, as an example. The third thing is that if you take a number, its absolute value is always going to be greater than or equal to it. Either a was positive and the absolute value of a is just equal to a, or a is negative, in which case the absolute value is positive and every negative number is smaller than every negative number is smaller than every positive number. The fourth thing, if you are multiplying numbers and take their absolute value, you can just multiply the absolute values of those numbers. When you take the absolute value of a times b, we're just taking whatever it is and we're making it positive. So I could just make whatever a is positive to begin with, and I could take b and make that positive to begin with. So we might as well just start with two positive numbers. Multiplication and division are actually very similar. So if I take a divided by b, and I'm taking the absolute value of the whole thing, I might as well just take the absolute value of a and the absolute value of b to begin with. Here, remember that we can't divide by 0, so b here should not be 0. However, the absolute value doesn't play quite as nicely with addition. It works very well with multiplication and division. With addition, we don't get exact equality, but we can say something. The absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b. This is called the triangle inequality. And this may come up a little bit this semester, but essentially to give you a picture, if you think of a and b being two sides of a triangle, the third side of the triangle can't be longer than the sum of the first two, otherwise your triangle would break apart. So this is just something to keep in the back of your mind. The last thing I want to mention is that we did talk about the absolute value being the distance between a number and 0. But what happens if I want to take, say, the distance between numbers that aren't 0? What about if I want to take the distance between, say, 1 and 4? How would I find that? Well, we can just count 1, 2, 3. So the distance between 1 and 4 should be 3. And we've got a nice formula for this. The way this works is that the distance between any 2 points, we take the absolute value of their difference. So for example, the distance between 4 and 1, I will take their difference and I'll take their absolute value. So this is going to be the absolute value of 3, and that happens to be 3. But with distance, it shouldn't matter if we're going from a to b or from b to a. So if I take the absolute value of 1 minus 4, I'm going to get the absolute value of negative 3, which we already saw as 3. So this is a handy trick to keep in mind as well. Let's say note, the absolute value of a minus b is equal to the absolute value of b minus a. Because it doesn't matter if you're walking forward or walking backward, you'll still travel the same distance.